Hello, welcome to our little corner on the web, where we go through math problems to inspire and encourage an interest for math. Today, we will go over questions 13 through 15 in part 2 of the 26 PMO qualifying stage. Question 13. Three lines with slope 1, 7, and C intersect to form a non-degenerate isosceles triangle. If C is between 1 and 7, what is C? So first, we'll try to sketch out on the Cartesian plane the lines with slope 1, 7, and C. So we'll have a line that's 45 degrees, which is the slope 1. We have a fairly steep line with the slopes 7, right? And then we will have this line that we're given that's sort of in between the two. So for now, we'll assume that it's some line like this. Okay, we don't know what it is. Could be 8/7, 13/7, 2, 15/7, something like that, right? And we're told that some combination of lines that has these slopes will form a non-degenerate triangle. So one way to do it would be to shift one of these lines to see if we can actually form isosceles triangles. So we have control over the slope of C, the slope of the blue line, which is C. So the ones that we can control the slope of are the two red lines. So what we'll do is we'll shift one of the red lines, the one with slope 7, over to this side, and hopefully it's clear that we can form a triangle. Not quite sure yet of the isosceles nature, right? But let's say that was the slope, this line that shifted to the right. Well, now we can play around with C, with the blue line, the one with slope C, to make this triangle here, I'll mark with a black, to make this triangle isosceles. So it's a matter of finding convenient points on those two red lines that make them equal, meaning this length here equal to this length here. So let's look at the lattice points or integer points of the one with slope 7. The one with slope 7 basically has to go from 0, 0 to 1, 7. Okay, so for unit 1 change in x, the length of that line is no more than square root of 7 squared plus 1 squared, which is square root of 50, or 5 root 2. Well, 5 root 2 is very convenient from a slope 1 line. That's basically from 0, 0 to 5, 5. So actually, the only thing we need to do is connect. You can think of it as a vector from 0, 0 to 5, 5, and 5, 5 to wherever that red one's going to land. But that's just delta 1 on x. So that will be 6, and 7 on y, 6, 12. So we just want the blue line to basically pass through 0, 0 and 6, 12. Well, the slope will be the change in y over the change in x. So that's 12 over 6, which is 2. So the slope C that we're looking for is slope 2. Okay. So moving on to the next question. Okay. Let AN be a sequence defined by A1 equals 17, AN plus 1 is equals to 2023 times AN all over 2023 minus 2AN. How many terms in the sequence are integers? Questions like this, I tend to see if I can find a pattern first. So we solve for the first few values of AN. So A2 will just be 2023 as defined times 17 all over 2023 minus 2 times 17. Okay, we want to be able to somehow simplify this. So we note that 2023, the prime factors are 7 times 17 squared. Okay, So we know that there's a factor of 17 in this first 2023 here. So this we can write as 2023 times 17 all over 17 times 17 times 7 minus 2. Okay, so the 17 sort of cancels. We're left with 2023 all over 119 minus 2, which is 117. Okay. So they're co-prime, so that's as simple as we can leave it at. So A3 is now 2023 times 2023 over 117 all over, again, 2023 minus 2 times 2023 all over 117. If we put both the numerator and denominator to be all over 117, those will cancel. So we have 2023 squared minus 2023 times 117 minus 2, which simplifies to 2023 all over 115. So actually, this pattern continues. So A4, if let's do A4 so that hopefully we can motivate that this pattern does indeed at least hold for A4. So same thing, we'll put them both over 115. The 115s will cancel. You end up with 2023 squared all over 2023 times 115 minus 2. So that's 2023 all over 113. So what you notice is we end up with basically the denominator having 119 minus 2, 117 minus 2, 115 minus 2, and it holds as we go forward. It will be 1111 next, 109. So the only question is basically when does this denominator become a factor of 2023? Okay, so we know that for A1 it holds. We could actually have written A1 as 2023 all over 119. Okay, or 7 times 17. Okay. So since we're decrementing by 2, it will hit all the factors of 2023. So it will hit, the first one is 119. The next one it will hit is 2023 divided by 17, and then 2023 divided by 7. And at some point it will hit 2023 divided by 1. Those will be the positive ones. If you extend it further, it will also hit 2023 over negative 1. And then after that, it will be negative 7, negative 17, negative 119. Okay. Did I miss anything? No, haven't yet. Okay, negative 119 will also hit negative 289 and negative 2023. So we'll hit all those as you decrement by 2. So there are actually 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 denominators, which will divide 2023 to be an integer. So there are basically 10 values that the sequence will result in an integer. After you hit minus 2023 as the denominator, then it will just be a fractional value, a negative fractional value, in fact. Okay, so here the answer is D, 10. Okay. So moving on to the next question. Question 15. Oh, okay. Question 15. Let ABCD be a square. Point E is in its interior such that AED is 90 degrees and EBC is equal to EAB plus 45 degrees. If AE is 9 root 2, find BE. Okay, well, let's try to draw this figure out. So we have a square. Okay, and we have some 90 degrees. So for now, I'll try to draw a semicircle. So it helps me draw a 90 degree. So because we know that the angle AED is 90, so it should be somewhere on that semicircle. So this is 90 degrees. Okay, this is point E. Okay. EBC is bigger than EAB. So we've sort of drawn it roughly accurately. So EBC is this angle, right? And if we let EAB be X, this angle be X, then this is X plus 45. Okay. So I'm going to introduce here another line to help us find things a little bit easier. So if I draw that diagonal line, then this thing here is X, and this thing here is 45. Okay. So we have an X and an X. So it's sort of maybe motivates that we try to find similar triangles. Since we already have one that's similar, but hopefully we'll find more. Okay. So note that angle EAB is equal to X, right? And we just showed that EBC is X plus 45, okay? And that led us to finding that angle EBD was X, okay? We also can show that angle ADE is actually equal to X because angle BAD is 90 degrees and angle and there's a right triangle AED, which means that angle EAD plus EDA must also be 90 degrees, right? But BAD is X plus, let's call this thing Y. So that means that this angle here should also be X. Okay. Okay. So with that, EDB here should be 45 minus X. 45 minus X. Okay. Meaning angle EDB. 45 minus X. But if you go back on top, this is also equal to angle ABE, 45 minus X. So in essence, we have two triangles which are similar. Triangle ABE is similar to triangle BDE. If they're similar, the ratio of the sides must be similar. So we're given that, we know that this is a square, so AB to BD is equals to 1 over square root of 2. Right, that BD is just the diagonal. So this leads us to AE is to BE is also 1 over root 2, but we're given what AE is. AE is 9 root 2. So we multiply both top and bottom by 9 root 2, 9 root 2 over 18. So BE is 18, or letter C. Okay. So hopefully you found these solutions helpful and educational. If you did, do hit the like button and subscribe. Thank you for watching.